Okay, welcome back, and here's another example of using compound interest. So in this example, Becky must pay a lump sum of $6,000 in 5 years. So the last example, so the last example was a deposit that was going to grow. Okay, now, so interest is working for you. In this example, you're talking about a loan that needs to be paid back, so interest is working against you, which means the longer it takes you to pay it off, the more interest you pay. But the compound interest formula, compound interest works exactly the same in both scenarios. Okay, so Becky borrowed money and she needs to pay it back in 5 years. So she borrowed $6,000, and so in the next 5 years, just so you understand how this is working, she's going to pay a lump sum, which means she borrowed $6,000 and she's going to have to pay it off in 5 years. Okay, the full amount. Okay, so she's not making any sort of payment arrangements. It's like, okay, after 5 years, you pay me my money plus interest. Okay, so now it says, what amount must be deposited today at a 3.1 interest rate, 3.1% interest rate, compounded annually, will grow to $6,000 in 5 years. Okay, so we need to figure out the P, right, principal. So because we need to have $6,000 in our account in 5 years to be able to pay back the $6,000. Okay, so this $6,000 is not accumulating interest in this case. We just want to make sure that we have the money in our bank account within 5 years. So this works exactly the same way as the last problem. Okay, so in this case, you're not being charged any interest on the loan, so that was my mistake. So there's no interest being charged on the loan. You just need to be able to pay that money back let's say you borrowed $6,000 from a friend. Okay, I would highly recommend never doing that. But let's say Becky decided to borrow $6,000 from a friend, and the friend said, you know what, just pay me back the full amount in 5 years. Don't worry about making payments. Just pay me back the $6,000 in 5 years. What amount must she deposit into an account today at 3.1 interest, compounded annually, so that in 5 years she'll have $6,000 and she can pay her friend back? Well, in this case here, what are the numbers? We need to figure out what the variables are. So again, R is going to be the 3.1% annual interest rate, which is 0.031 as a decimal. It's compounded annually, which means N is equal to 1, because it's only compounded annually, which means once per year. And $6,000, that's the amount she's borrowing, right? She borrowed. So she needs to have that amount of money in the future. So that means future value needs to be 6,000, or the accumulated amount needs to be 6,000. So A is 6,000. And T, of course, is 5 years. And so the thing that we're looking for is P. We need to know how much you need to put in the account today. That's present value. So in this case, P, right, we're still using the formula, right? So remember, the formula we start with is A equals P to the 1 plus R over N to the NT. Okay? Now, if we solve for P, all we have to do is divide both sides by this. And so we get P equals A over 1 plus R over N to the N times T power. And so now what I'm going to do is I'm going to just plug and chug now. So A is 6,000. And then 1 plus, now N is 1. So, and N is 1 here. So actually, all I'm going to do is end up with R, which is 0.031, right? Because 0.031 divided by 1 is 0.031. And then 1 times t is just t, so t is 5. So I'm just going to get 5 up here. So that simplifies things. And now, guess what? I'm going to grab my calculator. So what I'm going to do is I'm going to take 6,000 divided by parenthesis 1 plus 0.031 parenthesis, and then I'm going to put it to the 5th power. And so this is what I end up having in my calculator. Okay? So I've got everything in my calculator. And so I'm going to hit enter. And I end up with that. Okay? So again, I'm going to round to the nearest penny, which is going to be $5,150. Now, here's the thing. Since I need an amount, right, and since I'm rounding, in this case, since I have a goal I need to reach, well, I don't want to round down, so I'm going to round up. Okay, even though I would round up to the nearest penny, like this would be 60 cents, okay, but I'm going to be a little bit short because of round off here. So what I would do is I would round to the nearest dollar, again, because you have a goal, you have a financial goal. So it's always good to round up to approximately the dollar. But again, I'm going to round up to the nearest penny. So $5,150.61. So again, I rounded up because we have a goal. And in this case, I should have rounded down. If I was using regular rounding rules, I would round down. But again, we're talking about a financial goal. So it's always better to round up than to round down, because if we round down, we're going to end up being short. Okay? So I hope that makes sense. In this context, we're going to round up. Okay? Now, if I said the nearest dollar, if I wanted to round to the nearest dollar, then I would say that I would need to have $5,151 invested today. Okay. Now B says, what if only 5,000 is available? What if I only have 5,000? Okay. So here's what I need. But what if I only have 5,000? What kind of interest rate am I going to need now? So now we're solving for R. So now I've got my present value. So in this case, P is equal to 5,000. Again, everything else is the same except now we're solving for R. So T is equal to 5, N is equal to 1, A is equal to 6,000. Okay? And so now, what do I need to solve for? R. Well, how do I solve for R? Well, this is going to be an interesting one to solve, right? So if I solve for R, I have to deal with that exponential there. Okay? Now the cool thing is because this simplifies, right? It just simplifies to this. Let me rewrite this because n is 1 in this case. The formula actually simplifies to an easier formula to deal with. And again, this is given to in the textbook too, but is 1 plus r raised to the t power. Okay? So, now, but we still got an exponential we have to deal with. Okay, so how are we going to deal with that? Let's do it. So, we're going to solve for r. So we're going to divide both sides by p. So we get a over p equals 1 plus r raised to the t power. Okay? So let's plug in our values. So we've got, what do we end up with? We got 6,000 divided by 5,000 equals 1 plus point, oops, we're solving for r, I forgot. 1 plus r raised to the 5th power. Okay? So guess what? Well, in this case here, we're going to use our properties of exponents. Well, what do I need to do to get rid of that 5? I'm going to multiply, or I'm going to take the power of 1/5 power of both sides. So I'm going to take this to the power of 1/5, and then I'm going to take this to the power of 1/5, right? And then the power rule tells us to multiply these, and then what are we going to get? We're going to get, oh, by the way, we're going to simplify this too. This simplifies the 6/5. So this will give us 6/5 raised to the 1/5 power, and then guess what? It's going to equal 1 plus r, so if we subtract 1 from both sides, that's going to equal r. And again, just make sure you see this. So all I did was plug in values, and then you're going to divide by p, and then you get this. And when you plug in the values, you get this. And then what we're going to do is, since we had a 5th power here, we're going to raise both sides to the 1/5 power so that we get rid of these powers, because 5 times 1/5 using the power rule gives us 1, right? And so we get 5/6 to the 1/5 power. And then we have 1 plus r here left over. And all we have to do is subtract 1 from both sides. And that's going to equal r. And so now all I have to do is put that in my calculator. Okay? So again, I'm going to take the quantity (6 divided by 5) raised to the 1/5 power. And all I did was just do 1 divided by 5. And then I'm going to subtract 1. And so this is what I get. Okay? So I get that in my calculator. And if I hit enter, I get that. And so my interest rate is approximately what? 3.71%. Okay? Or if you round to the nearest decimal like they did, you'd want a well, I'd say 3.71 or 3.7. Okay? So, R ends up equaling, the interest rate we need is a 0.0371, which is equal to 3.71%. So that's the interest rate we would need to get. So we would need a higher interest rate to reach our target. And that's it. Have a great day.